Now look at carefully the structure of the X matrix. Please remember this is my X matrix. Okay, this is X matrix. So in the X matrix, the first column is all 1 1 1 1. Okay, all 1 1 1. Now what I'll do, I will ask you to think this X matrix in terms of this. So that means in this model, I have no other quantitative covariates but only this. Only this. So that means I will write the X matrix only in terms of the coefficient alpha, that means intercept, and this part D1, D2, D3, and D4. Right? So I will take this X matrix separately. So X is now, how is your X looks like? So this is 1 1 1 1 1 1. How many ones are there? In number of ones. And then you have this matrix, this dummy variables coefficient you have to take. Look at this. So this is now 1 0 0 0. So that means this will look like 1 0 0 0. Okay, and then 0 1 0 0, then 0 0 1 0, then 0 0 0 1. Again you will get 1 0 0 0 0 1 0 0, then 0 0 1 0. Likewise you will get. So this is for D1, this is for D2, this is for D3, and this is for D4. This would be your X matrix. Okay. Now, what we can do, if you go back to your basics of matrix algebra, any of these columns can be transformed by a simple linear transformation. For example, let us transform this D4 column, as D1 plus D2 plus D3 plus D4. Okay, this is how I am transforming this fourth column. So if you do so, what will happen? Your matrix will change like this. This is 1 1 1 1 1 1, and then D1 would be 1 0 0 0 0 0. D2 would be 0 1 0 0, then 1 0, then D3 would be 0 0 1 0 0 1, and then D4 would be now 1 1 1 1 1 1, because now I have changed the D4 into D1 plus D2 plus D3 plus D4, and if you take the summation, then it will become 1 1 1. Okay, it will become 1 1 1. Is that fine? Now look at this column, the changed D4 and these columns are actually identical. That means the elements of the first column, which represent the intercept, and elements of the transformed fourth column, they are similar. Okay, they are similar. And if that is the case, what would be the value of the determinants of x? So determinants of x, what would be the value? So if you know, the determinant of this value would be 0. Okay, determinants of this would be 0. And now if the determinants become 0, then how we have defined our beta hat? See, x prime x inverse x prime y, right? For this to exist, this matrix should actually exist, the inverse. Now the moment this becomes 0, okay, so beta hat beta hat is now non-existing. Okay, because adjoint A by date A, this requires what is the X inverse? X inverse equals to adjoint X by determinants X. And because this rule now determinants X is actually X is actually 0. So that means instead of the same rule, here we are talking about X. Actually, though, we will find the matrix of this X prime X is also does not exist because of this problem. So that means if you want to understand the actual problem of this dummy variable trap, you need to think about your X matrix, the structure of X matrix. You have the first column which represent the alpha, that means intercept, and since you have introduced 4 dummies for 4 categories, after transformation of D4, which is D1 plus D2 plus D3 plus D4, all the elements of this transform D4 is actually 1 1 1 1 1. So that means there is clear dependence. That means these 2 columns are collinear. That is why in Stata they said that due to collinearity problem, the 4th quarter is actually dropped. Now we are in trouble. Okay, we need 4 dummies to be introduced in the model, but the dummy variable rule says you will end up with this type of problem. So how will you solve that problem? To solve that problem, that means from the structure of the X matrix itself, you can understand that there is a simple mathematical solution for this. Okay, what is the solution? Solution is you just omit this intercept column. So that means if you omit this intercept column, then the problem is not there. That means the moment you introduce 4 dummies for 4 categories, while estimating the model, you need to ask Stata that I don't want intercept to be included in my model. And if you remove the intercept, then absolutely no problem in estimation. Okay, so that means what you have to do. If you want to estimate this type of model, then the solution is what you do. You reg FRIG and then D1, then D2, then D3, D4. You introduce 4 dummies, but you mention that I don't want any constant term to be included. Sorry. Oh, sorry. This is reg, then FRIG, D1 actually. D2, D3, D4, and then no constant. Now look at what is happening here. You have solved. Now Stata is not saying that 4 is omitted. All the coefficients you are getting. Okay, you have solved the problem by introducing 4 dummies. So basically, by omitting the elements of the columns, first column, you have overcome the problem of dummy variable trap. So what would be the interpretation of this model now? So that means in models where you have 4 dummies for 4 quarters and no other covariates included, then as I said, when you have this type of model, 4 dummies, and that means you have the model here is hello. Sorry, I'm in a meeting. So here we have 4 dummies, D1, D2, D3, D4. So that means you have to omit the intercept term alpha. And if you do so, then what would be the interpretation of beta 1, beta 2, beta 3, beta 4? I will show you the interpretation. So now you have cells equals to beta 1 d1i plus beta 2 d2i plus beta 3 d3i plus beta 4 d4i plus ui. Okay, ui. And now if you take expectation of cells given d1i equals to 1 and d2i equals to d3i equals to d4i equals to 0, then you will get beta 1. So that means beta 1 basically indicates cells in, rather mean cells in first quarter. Okay, similarly expectation of cells given d2i equals to 1 and d1i equals to d3i equals to d4i equals to 0 indicates beta 2. So that means beta 2 basically mean cells in second quarter. Similarly, expectation of cells given d3i equals to 1 and d1i equals to d2i equals to d4i equals to 0. This is beta 3. And then beta 3, that means indicate mean cells in third quarter. And expectation of cells when d4i equals to 1 and d1i to d2i equals to d3i to beta 4. Mean cells in fourth quarter. Okay, so that means coefficient of this dummy, they themselves indicate the mean cells. Okay, they themselves indicate the mean cells. So mean cells of the first quarter is 1 2 2 2, second quarter it is 1 4 6 7, third quarter is 1 5 6 9, and fourth quarter is 1 1 6 0. And if you look at the significance of these coefficients, all are significant at 1% level because the p-value is 0.000, 0.000. If you multiply that by 100, still it is 0.0. Okay, so they are directly giving the sales in each quarter, and all the quarters sales in each quarter is actually significant. So no quarter should be ignored by the salesperson. So all the quarters are significant, right? So this is the ANOVA model we have introduced. And if you look at the earlier model, basically, now if you compare, see D4 was omitted earlier. So that means when D4 is omitted by Stata is basically considering fourth quarter as the base quarter. That means the constant term here 1160 indicates sales of the fourth quarter. When you introduced 4 dummies with intercept, Stata dropped the fourth dummy. That means fourth quarter. and considered fourth quarter as the base quarter. And when fourth quarter is the base, the constant term obviously represent the sales of the fourth quarter. Now in this case, when you have 4, see this is exactly 1160, that is also 1160. And look at its standard error 59.9941, exactly matching. So that means whether you set this model or that model, the coefficients are coming actually the same. Okay, only thing is that there you have to consider the fourth quarter as base since it is omitted, right? Since it is omitted. Now what we'll do, in this model we have introduced only qualitative information, that means it was ANOVA model. All right, so if you consider uh, the quantitative covariate which was sales in durables, then your model will change. Like in this model I have introduced only 4 dummies, d1, d2, d3, d4. So this is basically the ANOVA model. This is ANOVA model, right? Now what I will do, I will make this model ANCOVA by introducing sales equals to, let's say, beta 1 d1i plus beta 2 d2i plus beta 3 d3i plus beta 4 d4i plus durables. Sorry, beta 5 DUI. That is the expenditure on durables plus UI. You can set either this type of model for dummies, or if your objective is to consider one category as base and include dummy, then you can introduce this type of model also, alpha plus beta 2 d2i plus beta 3 d3i plus beta 4 d4i plus beta 5 durables plus ui. So here, since we have already introduced the intercept, we consider d1i actually base category. And all these beta 2, beta 3, beta 4 and beta 5, they will indicate differential intercept, whether sales in other quarters are significantly different from the first quarter or not. That we will know by the significance of beta 2, beta 3, beta 4 and beta 5, right? So that whether you will say this model or that model, that again depends on the researcher's objective. If you want to compare other quarters with the base category, then this is the model. Second model. If you want to simply get, if you want to test whether sales in all the quarters are significant, then you have to set the first model, not the second model, because second, like the standard dummy variable model, will always give you the differential intercept, not the actual one. Okay, so you have to clearly keep in mind. So while model 1 gives you, in model 1, beta 1, beta 2, beta 3 and beta 4, they are giving direct intercept for first quarter, second quarter, third quarter and fourth quarter. Okay, so in model 1, beta 1, beta 2, beta 3 and beta 4 are intercepts in first, second, third, fourth quarter respectively. But in model 2, beta 1, beta 2, sorry, beta 1 is not there. Model 2, beta 2, beta 3, beta 4 are differential intercept. Differential intercept, and the difference is with respect to the first quarter. This you have to understand. 4 dummies means they directly give you intercept. 3 dummies means it is always in comparison with the first quarter. That is why differential intercept. Okay, and since we have introduced the other covariate, it is called the ANCOVA model. Now, if you do so, if you estimate the ANCOVA model taking 1 as base category, then what we'll do? Let's say reg FRIG, then let's say D2, D3, D4, and durables. Okay, durables we have taken, and let us know this. So what you will know now, see, in this ANOVA model, now it shows that fourth quarter sales in fourth quarter is not significantly different from the first quarter. That would be your interpretation, because the corresponding p-value is 0.202. If you multiply that by 100, it would become 20. So that means you are committing 20 type 1 errors while rejecting the null. So that means it is not significant. But D2 and D3, they are significant at 1% level. So that means we can say the sales in second and fourth quarters, second and third quarters are significantly different from the first quarter, but sales in fourth quarter is not significantly different from the first quarter. Okay, and it also shows that the impact of the quantitative covariate, which is expenditure on durables, is highly significant. For every additional unit expenditure on durables, your sales in refrigerator increases by 2.77 unit. 2.77 unit. And one more thing you have to keep in mind, in this model, we have not interacted the dummy variables with the quantitative covariate. What does it mean? It means that the responsiveness of cells with respect to durables are same across different quarters. Okay, across different quarters. When durable expenditure on durable increases by 1 unit, cell will on an average increase by 2.77 unit for each quarter. For each quarter. If you believe that different quarter will respond differently for this additional expenditure, then you have to interact the seasonal dummies, quarter dummies with this covariate. But that we are not doing it here, assuming they are same. We are not complicating the model. But we have to keep in mind, okay, every additional expenditure on durables result in 2.77 unit more cells in refrigerator. Okay, and if you introduce 4 dummies, reg, then D1, D2, D3, D4, and durables, you have to mention no cons. That means I don't want intercept. And then what is happening? Here also, you look at sales in all the quarters are significant, but sales in fourth quarter is significant only at 10% level, because the p-value is 0.54. So if you multiply by 100, it would become 5.4, which is greater than 5 but less than 10, significant at 10%. But as I said earlier, the econometrician, they suggest that we should take significance only at 1% and 5%. So that means we will say that this particular result shows that we have very weak evidence of cells in the fourth quarter. And obviously, since it is refrigerator cell, fourth quarter is basically starts from October, November, December. And October, November, December time is not very suitable, favorable for refrigerator cell. Okay, that time temperature is quite low. So without refrigerator also you can manage, right? So that is why probably this data shows that in the fourth quarter sales for refrigerator is not that significant. Okay, not that significant. And durables is again 2.773424. That means even if you introduce 4 dummies also with no constant, the responsiveness of your free refrigerator cells with respect to durable expenditure is almost the same, 2.77. Okay, this is how you have uh, to accommodate the seasonal fluctuation in your model. Otherwise, your model may end up giving some spurious regression. Okay, spurious regression. So in this example, in this exercise, what we were doing, we were basically trying to remove the seasonal fluctuation from the dependent variable. But what about seasonal fluctuation on the quantitative covariate? That means the expenditure for durables. That we have not done. But interestingly, there is a theorem which says that when you include dummies to eliminate the seasonal fluctuation from your dependent variable, automatically it removes any sort of seasonal fluctuation from the independent variable as well. You don't have to do anything additional. Okay, how will you check that? There is a way by which you can check that. See, initially we said that our objective is to remove the seasonal trend from this. And how will you do that? That means you have, let's say you have sales data for each and every quarter, first, second, third, fourth, then again first, second, third, fourth. You have actual data, you have, sorry, actual data. If you remove YIT hat for that quarter, you will get the data on YT which is completely free from the seasonal fluctuation. So YI minus YT minus YT hat. So this YT minus YT hat is basically your data free from seasonal fluctuation. Seasonal fluctuation. Okay, and in the process your xt is also eliminated. Okay, the any sort of seasonal fluctuation is eliminated from xt as well. That is the beauty of this procedure. Okay, that is the beauty of this procedure. So how will you check that? If you regress this data with xt, so that means if you regress YT minus YT hat on XT, then the coefficient what you will get, and if you regress the same procedure if you follow, then XT minus XT hat That means you have to take xt as your dependent variable. Your durables would be the dependent variable. Then your alpha plus beta 1 d1i plus beta 2 d2i plus beta 3 d3i plus beta 4 d4i plus ui. In the same procedure, if you remove, if you now subtract the predicted xt, which is dependent variable here, from xt, then what you will do, if you run that, use that as explanatory variable, you will get same sort of coefficient. That is proof. So there is no need for removing seasonal fluctuation separately from the explanatory variable. The procedure itself take care of any sort of seasonal fluctuation that might exist present in the context of xt as well. So with this, we are basically closing our discussion on dummy variable. Okay, we are closing our discussion on dummy variable. Now, so far, if you think about all the dummy variable models, then we use dummy for some of our independent variables. For example, here we are using dummy for the season or quarter, which is independent. But it may so happen that your dependent variable also is qualitative in nature. So that means so far we have discussed only dummy for independent variable. But we have not discussed dummy for dependent variable. And that we will discuss later on by three types of qualitative response model: linear probability model, then logit model, then probit model, and the tobit model. That we have not yet discussed. That we'll discuss later on. Okay, so with this, we are basically closing our discussion on dummy variable, where dummy was used to quantify some of the qualitative explanatory variable. Some of the qualitative explanatory variable. We have not yet discussed anything to convert the qualitative dependent variable into quantitative one using dummy. That we'll discuss later on by these four models. Thank you very much.